Hello, Professor Vaibhav Shah here. Our today's topic is projection of planes, and we will be dealing with rectangle and square as our objects. So let us start. So first, what is a plane? A plane is a two-dimensional object having its surface with only two dimensions, length and breadth, and has no or negligible thickness. A plane surface may be of any shape, circular or polygon. Circular means circle, semicircle, or a quarter circle. Polygon means multiple, gon means sides. So any object having more than two sides is known as polygon. This polygon can be divided into two categories, regular polygon or irregular polygon. Regular polygon means polygon having sides, all of these sides of equal dimension is known as a regular polygon, and irregular polygon means polygon having all of its sides with a different dimensions or a different lengths is known as irregular polygon. In this topic, we'll be dealing with square, pentagon, hexagon, circle, equilateral triangle, right angle triangle, and a rectangle. So now, in projection of planes, we'll be dealing with plane figures which are our subjects or which are our objects. Now, what is usually asked in the problem? So we have to draw the projection of these planes, means their front view and top view in stage 1, stage 2, and in stage 3. Now, what will be the given in the problem? So these three items would be given in the problem. First, description of the plane like dimensions, size, and shape of the object. Second, resting condition of a plane like resting on HP or resting on VP on its shorter or longer edge or a corner or a side. 3, its position with respect to HP and VP will be given like theta, plan, top view would be given for HP, and phi elevation front view would be given for VP. In which manner its position with respect to HP and VP will be given? So first, inclination of its surface with one of the reference plane will be given. Second, inclination of one of its edges with another reference plane would be given. Hence, this will be a case of an object inclined to both the reference planes, HP as well as VP. Now, let us study the illustration showing surface and side inclinations. Now, our first object is rectangle. As you can see, rectangle is having two sides. One is called as a small side or a shorter side of the rectangle, and another side is known as a longer side of this rectangle. So for the case of rectangle, let us observe and note these following steps. So we'll be taking the three cases for this rectangle. So in the first case, the surface of rectangle is parallel to HP. In second case, surface of rectangle would be inclined to HP. And in third case, one of the small side would be inclined to VP. So now let us start with this rectangle. So as you can see, this rectangle is placed just parallel to your HP, which is your surface of rectangle is now parallel to HP. In the second case, we'll be inclining this surface of rectangle with respect to HP. So as you can see, there is one line which is parallel to HP. This is nothing but the reference line which is parallel to HP. So we have made this inclination with HP at certain angle theta. So as you can see, our rectangle is now inclined at angle theta with HP. In the third case, we'll be inclining any small side inclined to VP. So we have to select any smaller side of your rectangle, and we have to make this inclination of this side with your VP at any certain angle phi. Now let us start with the first stage figure. So if we try to take the front view in this first stage, if we try to observe this object from this front view direction, we can see this straight line on this direction. So it will give us a horizontal line on this vertical plane, which is nothing but your front view of the first stage. If we try to observe this figure from this top view direction, we'll be getting the rectangular shape view on your HP. This is nothing but your top view. And as you can observe, the rectangular figure in your top view is similar as of your true rectangular shape and size. So this is your true shape of your rectangle with the two dimensions, which each of the dimensions of this rectangle are both the same in this case. Now let us take the projection for the second case. If we try to observe this object from this front view direction, we'll be getting one line inclined at certain angles. So as we can see, our rectangle is inclined to HPY angle theta. We are having the same inclination theta in our vertical plane. So this is nothing but our front view of the second stage. If we try to take the top view on this stage from this top view direction, so we'll be getting one rectangle, but this rectangle would be of the shorter size. This can be said as apparent length of this rectangle. So as whenever an object is inclined to any plane, we'll be getting one view which is of a shorter length in dimension is known as apparent shape of that dimensions. Now let us take the third stage. So if we try to take the front view in third stage, it will give us a inclined rectangle. As we can see, this is nothing but your third stage front view. And if we try to take the top view in third stage, it will give an inclined rectangle in third stage itself. Now as we can see, this is your three-dimensional object. So if we want to convert this into simple orthographic projections, we will be converting this three-dimensional object into two-dimensional object by rotating this horizontal plane in clockwise direction around this vertical plane. So if we try to rotate this HP in clockwise direction around this vertical plane, we'll be getting this as a final answer, which is nothing but your orthographic projection of a rectangular plane. So if we similarly apply the same procedure for second stage, we can get this as a final answer. And similarly, we have to apply the same process for the third stage. We'll be getting this as our final answer. So as we can see, orthographic projection of plane is nothing but a three-stage process. In first stage, we will be putting our object in HP, which is your surface is parallel to HP. After that, we will be getting one straight line, which is nothing but the surface of a rectangle. This is a straight line which is denoting the surface of rectangle. In second stage, we will be inclining the surface at any angle theta with respect to HP, as it says that surface is inclined to HP in your second stage. After inclining this line, we'll be drawing from each and every point vertical line, and from each and every point on your top view of first stage horizontal line in rightward direction to obtain this top view in second stage. After that, we'll be redrawing this image of your second stage in your third stage as your initial figure, and after that drawing this image at one of the small side inclined to VP. That means we'll be inclining either A1 B1 small side or D1 C1 small side at certain inclination with VP. So here we have taken the D1 C1 side at certain inclination with VP. So we have inclined this side and we have redrawn this figure of your second stage into third stage. And after drawing this figure, we will be plotting vertical line from each and every point, and we'll be drawing horizontal line from your inclined surface on the right hand side to obtain our final object, which is nothing but your front view in VP. So this total procedure is divided into three stages: stage A, stage B, and stage C. So now, what is the procedure of solving any problem or any projection of plane problem? So there are three steps involved in any problem solving, as we have seen in our previous illustration. Step 1, assume a suitable condition and draw the front view and top view of an object in your stage 1. Step 2, now consider the surface inclination and draw the second stage front view and top view. In stage 3, consider the side and edge inclinations and draw your third stage front view and top view. Now, assumptions for initial position in step 1. So initial positions mean assuming surface either parallel to HP or parallel to VP. So first, if in the problem surface is inclined to HP, then it is assumed that surface is parallel to HP or object is resting on HP itself. If the surface is inclined to VP, it is assumed that the object is parallel to VP or object is resting on VP itself. Now, if the surface is assumed parallel to HP, that means it is obvious that top view will show the true shape in HP. And if the surface is assumed to be parallel to VP, it is obvious that front view will show the true shape in VP. Hence, we have to begin with our drawing with top view or front view as a true shape in stage 1. While drawing this true shape, keep one side or edge which is making inclinations perpendicular to XY line, similar to drawing A on previous illustration. Once again, while drawing this true shape, keep one side or edge which is making inclination perpendicular to XY line. So let us observe in our first case, we have made this line which is made vertical in the first stage, vertical, or which is made 90 degree to your XY line. Or in other words, you can say you have to put the side which is inclined to on the left hand side of your drawing to start your drawing with. So now let us see complete step 2 by making surface inclined to your respective planes and project its other view. So let us refer the stage number 2 drawing. So this is nothing but your straight line which is defining the total complete surface of a rectangle. So we have to make this line incline at certain angle theta, in this case inclined with HP. So we have to make this line incline with HP. After drawing this line, we'll be drawing vertical line from each and every point and horizontal line from each and every point from your top view in first stage to obtain the top view in second stage. Now complete the step 3 by making the side inclined to respective plane and project its other view. So it is nothing but we will be redrawing this figure at any given angle with respect to VP. So here it said that one small side is inclined to VP. So we have selected this small side which is made inclined to VP and we have redrawn this image. After drawing this image, we'll be drawing vertical line from each and every point and horizontal line from your inclined surface to get our final object or final front view in the third stage. So this is nothing but the procedure of solving any problem, any projection of plane problem. So now let us start with the first problem. So problem number 1, rectangle 30 mm and 50 mm sides is resting on HP on one small side which is 30-degree inclined to VP, while the surface of the plane makes 45-degree inclination with HP. Draw its projection. So read the problem and answer the following questions before starting to draw. So first question, surface is inclined to which plane? So let us see, surface of plane makes 45-degree inclination with HP. So now your surface is inclined to your HP. So our first answer would be HP. If your surface is inclined to HP, that means that your initial position would be parallel to HP. So your plane would be parallel to HP. If your plane would be parallel to HP, it is obvious that the true shape would be of the top view and which will lie in HP itself. Now the final answer, so which side will be vertical? So it is said that it is resting on one small side which is inclined at 30-degree to VP. So it is nothing but your one small side which we have to make vertical while drawing the object in your horizontal plane. So hence we will begin with the top view by drawing the rectangle below XY line in HP and drawing the one small side vertical. So now let us start. So first we will draw our XY line. After this, we will try to draw this rectangle. In this rectangle, our one small side would be either vertical, or we can say we have to put this small side on the left hand side of your object to start our drawing. Now we'll be giving the notations in anti-clockwise direction A, B, C, D. After getting this top view in initial first stage, we'll draw through each and every point one vertical line to get the front view on this XY line, and this is nothing but your dash points. And as we know, front view is denoted by the dash points. So this is nothing but your front view A dash, B dash, C dash, D dash. And this denotes the surface of the rectangle by a one single line. So as now our object is resting on HP, we'll be solving the condition for HP first. So condition for HP is surface of the plane is now making an angle 45 degree with the HP. So this is your surface of plane. We have to make this line 45 degree to HP. So XY line and below this portion is your HP. So we'll be making one 45 degree line above this XY line. So let us make this 45 degree line above this XY line. On this line, we'll be plotting these points. So A dash B dash point would be starting point of this line and C dash B dash point would be ending point of this line. So let us denote these points on this line. After getting this line, we'll be drawing the vertical line from each and every point and horizontal line from this previous figure to find out our top view in the second stage figure. Now, on the horizontal line of A and vertical line of A dash, we'll be having this point A1. On the horizontal line of B and vertical line of B dash, we'll be having point B1. So similarly, find out your points C1 and D1 and try to join these points by your alphabetical order. You will be getting the top view in second stage. Now let us find out the third stage, final inclination. So here it is said that one small side which is 30 degree inclined to HP. So we have to make any small side. We are having two small sides, A1 B1 and D1 C1. So we can select either of the sides and we can make these sides inclined at 30 degree to VP. So first, this is your VP above your XY line. So the angle with your VP will be below this XY line. So let us construct one angle which is 45 degree inclination to HP. So this is your 45 degree inclination line. We have to put any small side on this line. So I am taking this side A1 B1 and I am putting this side here, and I will try to redraw this figure once again on this third stage. So if I try to redraw these figures, I will be getting this figure as my redrawn figure in the third stage. Now, after getting this figure, I will be drawing vertical line from each and every points from this stage number 3 figure. So I will be drawing vertical lines from each and every points. After that, I will be drawing horizontal line from your surface, inclined surface, and I will be identifying the points of intersection A, B, C, D. Likewise, we have obtained in the stage number 2 here. So after getting this point, join these points by alphabetical order. You will be having your final object, which is inclined to both HP as well as VP, and which is your required front view. Now, let us see one more example. Problem number 2. A thin rectangular plate of sides 60 mm by 30 mm has its shorter side in VP and incline at 30 degree to HP. project its top view if its front view is square of 30 mm long side. So it is said that we are having one object with the side 60 by 30 mm as a rectangle, has its shorter side in VP. That means we have to put a shorter side vertical in VP, or either we can say we have to put this shorter side in left hand side of the drawing in VP. So let us draw the rectangle by 30 by 60 mm sides. After drawing this rectangle, let us give the notations with the dash points, as we know that in VP we are having the front view. So front view is denoted by always by dash points. Will be specifying A dash, B dash, C dash and D dash. After this front view, we will be drawing vertical line from each and every point to obtain the top view on this XY line, which will be your ABCD, which is nothing but your surface of your rectangle. Now for second stage, as your object is resting on your VP, so we'll be solving the condition for VP first. And here you can see the front view is a square of 30 mm side. So front view is nothing but your drawing or object in your vertical plane. So we have to first draw this front view in your second stage, and after that we can find out the inclination of this surface with your vertical plane. So let us draw this front view in your second stage. So for that, we know that the distance between A dash B dash and distance between C dash D dash is obviously 30 mm. If we try to draw the horizontal line from your B dash C dash, and if we try to draw the horizontal line from C dash D dash, the vertical distance would be 30 mm, which is fixed. So now here we will first identify point B dash somewhere here, and we will try to draw one vertical line. We will find out one A1 dash. Now this is your 30 mm fixed. Now we have to make the square of 30 mm sides. Each side should be 30 mm. So we'll be converting this 60 mm into 30 mm. So for that, we'll be taking 30 mm on our rounder. Put your rounder at point B1 dash and try to cut this line and to get the point C1 dash, which is 30 mm away from your B1. After getting this point, put your rounder at A1 dash and try to follow the similar procedure to get the D1 dash, which is 30 mm from your A1. And try to join these points. We'll be having one square, which is required square, front view square, which is 30 mm long sides. Now we have to go reverse. So we will be plotting vertical line from each and every point A1 dash, B1 dash. We'll be having this point as AB, which is the starting point of your inclined surface. And as we know, your surface gets inclined, your point C dash, D dash will give you point C dash, C and D somewhere here in space. So we'll be taking the dimension of this true length of your surface, which is AB to CD, which is 60 mm on your rounder. Try to put your rounder at AB and try to cut this vertical line of C1 dash, D1 dash, and we will be having this intersection point as CD. So this is nothing but your surface of 60 mm, and if we try to find this angle, so this will be your angle with respect to your VP, and which is your required angle of second stage, which is at which the surface is inclined or to your vertical plane in your second stage. Now for the third stage, we'll be taking the condition with respect to HP now. So now it is said that the rectangle has its shorter side in VP, and the side which is in VP is inclined at 30 degree to HP. So as we know that this is the side which is resting on the left hand side, it is resting in VP. So in second stage drawing, this is your side which is resting on VP. So we have to make this side incline at 30 degree to HP. So XY line and below this XY line portion is your HP. So we'll be drawing 130 degree above this XY line to get the 30 degree inclination with your HP. After getting this inclination, we'll be putting this side, which is a shorter side, which is resting on HP in the first stage. So we'll resting on VP in the first stage. So let us put this side A dash B dash on this 30 degree line and try to redraw this figure of the second stage into third stage. So this will be our starting figure of the third stage. After getting this figure, we have to draw the vertical line from each and every point, and from the horizontal line from this surface to get this final object, which is our required image, which is our required top view of the third stage. Now let us see one more example, problem number 3. A thin rectangular plate of side 60 mm and 30 mm has its shorter side in the HP, and the plane is 20 mm away from HP. Project its front view if its top view is a square of 30 mm long side. So here our object is once again rectangle with 60 mm 30 mm side, has its shorter side in HP. So we have to put its shorter side in HP, which is vertical line, or we can have the shorter side on the left hand side, which is 30 mm side. So we have to draw this rectangle by 30-60 mm. We'll be giving the numbering ABCD in anti-clockwise direction. Now after this, it says that the plane is 20 mm away from HP. 20 mm away from HP, that means this is your XY line, below this portion is your HP. So 20 mm away from HP means 20 mm away from your XY line in this direction. So it says that your projection, any of the further projection would be lying on this line 20 mm away from your XY direction. So now we'll be plotting the vertical lines from each and every points, and we'll be getting the front view on this line 20 mm away from your XY line, which is nothing but your surface in the first stage, which is a front view, A dash, B dash, C dash, D dash. As you can see, this is a 20 mm distance. So this is a 20 mm away from your XY line. So now in this case, your projection would be at 20 mm away distance from your XY line. After this, as your object is resting on HP, we will be solving the condition of HP first. So as we know that the top view is a square, so top view is nothing but your view on your HP. So we have to first obtain this top view in HP. So we know that the vertical distance between AB and CD would be constant, which is 30, which can't be changed. So if we try to draw the horizontal line from AD and BC, it will give a 30 mm vertical distance. So for that, we'll be drawing one horizontal line. We will try to identify A1 point and we'll try to draw one vertical line. We'll be getting this point B1. Now, if we want to convert this AD into 30 mm, we will select 30 mm on our rounder. We will put our rounder at A1 point and we'll try to cut this line to get this point D1. Similarly, we will put our rounder at B1. We will try to cut this line and to get the point C1, which is 30 mm away from your points. If we try to join these points in alphabetical order, we will be getting the square in top view, which is the required length of square, which is a 30 mm long side. After getting this square, we want to obtain the inclination of the surface of the first stage. So we'll be reversing the drawing. So we'll be drawing one vertical line from your A1 B1 to intersect this 20 mm of a locus. We'll be getting the starting point of this surface, which is A dash B dash. So this is your point A1 B1 dash. Now as we know that the C1 D1 points would be somewhere here in space on inclined surface here. So we'll be taking the dimension of A dash B dash to C dash D dash, which is 60 mm in the first case, and we'll try to put our rounder here on A1 dash B1 dash, and we'll try to cut this vertical line of your C1 D1 to obtain these points C1 dash D1 dash. If we try to join these points, we'll be having one angle theta, and if we try to measure this angle, this is the required angle at which the surface should be inclined to get the square as a top view in your second stage. Now let us move to our next object, which is a square. So as you can see, square is having almost equal dimension. So square is only object which is having a 4 of its dimension of a equal length. We'll be having only single length to draw a square object. So let us start the example about square. So problem number 1, a square ABCD of 50 mm side has its corner A in HP. Its diagonal AC is inclined at 30 degree to the HP and diagonal BD is inclined at 45 degree to VP and parallel to the HP. Draw its projections. Here it is said that you have to draw one square 50 mm side and has one of the corner A in HP. So that means your object is resting in HP. So we will be drawing square resting on one of the corner in HP. As we know that corner is resting on HP, that means your corner should be vertical. So here your corner is vertical, or either in other words, your corner should be on the left hand side. Here the corner is A. So you must draw this point as your corner A. After this, we will be giving the numbering ABCD as it is in HP. So it will be without dash. After drawing this top view in first is we'll be plotting vertical lines to intersect the XY line to get our front view, which is A dash, B dash, D dash and C dash. Now as our object is resting on HP, we'll be solving the condition for HP first, in which the condition of HP is diagonal AC is inclined 30 degree to HP. So we'll be drawing one line 30 degree to HP. On this line we'll be inclining this diagonal A dash, C dash. So try to mark each and every point of this line onto this 30 degree line. So this is your nothing but your surface is inclined at 30 degree to your HP. After drawing this line, we'll be drawing vertical lines from each and every point, and we'll be drawing horizontal line from each and every point from stage number 1 top view. We'll be getting this rhombus as a final image in stage number 2. Now after that, we'll be taking the final condition, which is the diagonal BD is inclined at 45 degree to VP and which is parallel to HP. So as we can see, the diagonal BD is already resting in HP. That means it is obviously parallel to HP. Now we have to make this diagonal incline at 45 degree to VP. So as we know that this is your XY line, above this is your vertical plane. So 45 degree line to your vertical plane would be your line below your XY line. This is your 45 degree line. Now let us check. In stage number 2, your BD dimension is this. In stage number 1, your BD dimension is same. So in stage number 1 and 2, the BD dimension is same. There is no conflict in dimension. So we can directly put our BD diagonal onto this 45 line. For that, we'll be selecting any point B1 anywhere on this line. Take the dimension of B1 to D1 on your rounder. Try to cut this line and you will try to redraw this figure on your third stage. After redrawing this figure, we will just draw a vertical line from each and every points and horizontal line from your inclined surface to get the final front view of the third stage. Now let us see one more example. Problem number 2. The figure is the top view of square having 100 mm diagonals. Draw a rhombus of 100 mm and 70 mm long diagonals and make its longer diagonal horizontal. Draw its front view. So here it is said that our first stage figure is top view, and which is a square. So we'll be drawing one square which is having a 100 mm by 100 mm diagonal. So let us draw two diagonals, 100 mm and 100 mm, and try to complete this square. After drawing this square, let us give the numbering A, B, C, D. After drawing this square, in the first stage we'll be trying to plot the front view on XY line. So let us draw one vertical line from each and every point to obtain this front view A dash, B dash, D dash, and C dash. Now, as your object is resting on HP, so we'll be taking the condition for HP first, which is draw the rhombus of 100 mm by 70 mm long diagonals. So as we can see, if we try to draw the horizontal line from the B and point D, so it is obvious that your point B will lie somewhere here and point D would lie somewhere here. So distance between B and D, which is fixed, which is 100, so it can't be changed, but we have a liberty to change the distance of AC because we want a rhombus of 100 mm by 70 mm diagonals. If your BD is fixed as 100, so we must change the diagonal AC to 70 mm to get our required rhombus. So for that, we'll be drawing one horizontal line from this point AC. Try to locate this point A1 on this horizontal line and try to cut this 70 mm long diagonal distance on the rounder. On this horizontal line, we'll be having this point C1. After getting this point A1 and C1, try to reverse this drawing. So we'll be plotting this vertical line from your A1 to obtain this A1 dash or A dash, which is the starting point of your inclined surface. And as we know that if your surface is inclined, so your C1 dash point will give you point C dash on this inclined line somewhere here. To get this inclined line, we will be taking the dimension of A dash to C dash and put your rounder at point A dash and try to cut this line of C1 at point C dash here. So we'll be having 2 points A dash and C dash. Try to join these 2 points A dash and C dash and obtain this point B dash and D dash. How to obtain this point B dash and D dash? So let us select by your rounder A dash to B dash D dash dimension on your rounder. Try to put your rounder at A dash and try to cut this line. You will be having your B dash D dash. After getting these 3 points A dash, B dash, D dash and C dash, we will draw one vertical line from each and every point and draw horizontal line from each and every point. We will get one rhombus, which is our required rhombus of 100 mm by 70 mm long diagonal. So this is our required rhombus in the second stage. Now, for the last condition, make its longer diagonal horizontal. So let us check in the second stage. This is your longer diagonal. This AC would be your shorter diagonal. So we have to make this longer diagonal horizontal. So for that, we will be taking this dimension of this longer diagonal, draw one horizontal line and put this longer diagonal on this horizontal line. After drawing this horizontal line, we will just redraw this stage 2 drawing into stage 3 initial drawing. So after this, we will be having this drawing as your longer diagonal is horizontal. Now after drawing this drawing, you will draw vertical line from each and every point and horizontal line from your inclined surface to get the final image or final front view, required front view in your third stage. So now this is the end of your presentation. Now I will always say persistence is the magic. So keep persistent while practicing. You will be 100% successful. Thank you.